Start the engine of a 1970s performance car and something immediately feels different. The idle is uneven. The steering wheel vibrates slightly. The exhaust note is not filtered or softened. Press the throttle and the response feels direct, almost physical, as if cables and fuel are reacting instantly to your foot. Drive a modern car right after and the contrast becomes obvious. Smooth, insulated, refined, efficient, safer. Faster in many cases, but less raw. Why do 1970s classic cars feel so mechanical compared to modern vehicles? The answer lies in engineering philosophy, regulation, materials, technology, and the evolution of comfort expectations. In the 1970s, cars were still largely mechanical systems with minimal electronic intervention. Throttle input was controlled by a physical cable connected directly to the carburetor. When you pressed the pedal, airflow changed immediately. Fuel delivery adjusted mechanically. The sensation of acceleration was not interpreted by a computer before reaching the engine. There was no delay introduced by electronic smoothing. That direct linkage created a strong sensory connection between driver and machine. Carburetors themselves contributed to the raw feeling. Unlike modern fuel injection systems that precisely meter fuel dozens of times per second, carburetors relied on airflow and vacuum pressure. They were effective but imperfect. Cold starts required choke adjustments. High-altitude driving could affect mixture. Sudden throttle inputs sometimes produced hesitation. These imperfections created character. Drivers were aware of the engine's temperament. Steering systems in the 1970s were also fundamentally different. Many vehicles used hydraulic power steering or even manual steering without assistance. There was less isolation between the steering wheel and the front wheels. Road texture, bumps, and tire grip translated directly into feedback through the column. Modern electric power steering systems prioritize efficiency and comfort. They filter vibration and reduce effort, but in doing so, they remove some tactile communication. Suspension design played a major role in mechanical sensation. Older cars often used simpler suspension geometries and softer chassis structures. Body roll was more noticeable. Weight transfer during braking and acceleration was more dramatic. You could feel the mass of the car shifting around you. Modern cars use advanced multi-link suspension systems, rigid chassis engineering, and electronic stability systems that minimize dramatic movement. Stability increases, but sensation decreases. Braking systems evolved significantly as well. In the 1970s, braking field depended entirely on hydraulic pressure applied by the driver. Anti-lock braking systems were rare or non-existent. When tires locked, the driver had to modulate pedal pressure manually. This required skill and awareness. Modern braking systems use electronic sensors to pulse brake pressure automatically, preventing lockup and maintaining control. Performance improves, but driver involvement changes. Transmission design further separates eras. Manual gearboxes in the 1970s often required deliberate input. Clutches were heavier. Shifters had longer throws. Synchronizers were less refined. Each gear change felt like a mechanical event. Modern manual transmissions are smoother and lighter. Automatic transmissions in the 1970s were slower and less efficient, often with fewer gears. Today's automatics shift in milliseconds and optimize fuel economy electronically. Chassis rigidity also transformed the driving experience. Older cars typically had less torsional stiffness. The body structure flexed slightly under stress. This flex could be felt during cornering or over uneven roads. Modern vehicles are engineered with advanced materials and computer modeling to achieve extreme rigidity. This improves safety and handling precision, but reduces the organic sensation of structural movement. Sound insulation dramatically increased over time. In the 1970s, cabins allowed more engine noise, exhaust resonance, road sound, and wind intrusion. Drivers heard mechanical systems working. Modern cars use insulation materials, acoustic glass, and engineered engine mounts to suppress noise. Quiet cabins enhance comfort but distance occupants from mechanical activity. Safety regulations significantly influenced design philosophy. As crash standards tightened over decades, manufacturers added reinforcements, crumple zones, airbags, and impact absorption structures. These additions increased weight and complexity. Engineering focus shifted toward occupant protection. While this progression saved countless lives, it also transformed how vehicles feel dynamically. Emissions regulations changed engine behavior. In the early 1970s, muscle cars often produced strong low-end torque with minimal emissions control. As regulations intensified, engines were detuned temporarily before fuel injection and catalytic converter technology matured. Modern engines balance power, efficiency, and emissions with computer precision. Performance is cleaner and often faster, but delivery is refined. Driver aids represent one of the largest differences. In the 1970s, traction control, stability control, adaptive dampers, and drive modes did not exist. Tire grip limits were explored directly by the driver. Mistakes were punished immediately. Modern vehicles monitor wheel speed, yaw rate, throttle position, and steering angle hundreds of times per second. Computers intervene before loss of control becomes severe. This increases safety but reduces raw unpredictability. Material choices contributed to tactile difference. Metal dashboards, chrome switches, mechanical knobs, and analog gauges dominated interiors. Each component had weight and resistance. Modern interiors rely more heavily on plastics, touchscreens, and electronic interfaces. Digital displays replace mechanical dials. Interaction becomes visual rather than mechanical. Weight distribution and tire technology evolved as well. Older tires had less grip and narrower profiles. Handling characteristics were more progressive and sometimes less predictable. Modern performance tires provide immense traction. Combined with advanced suspension tuning, they create stability that older vehicles could not match. Fuel economy pressures also shaped modern refinement. Aerodynamic efficiency, reduced rolling resistance, and optimized gear ratios aim to maximize miles per gallon. In the 1970s, especially before the oil crisis, performance often outweighed efficiency considerations. Engines were larger, compression ratios were tuned differently, fuel consumption was less scrutinized. Despite these advancements, many enthusiasts prefer the analog experience of older vehicles. The absence of electronic filtering creates emotional intensity. Every vibration, noise, and steering correction feels meaningful. The driver must pay attention constantly. Engagement is not optional, it is required. However, it is important to recognize that rawness often included drawbacks. Reliability issues were more common. Maintenance intervals were shorter, weather sealing was weaker, rust protection was limited. Comfort during long journeys could be tiring. Modern refinement solved many practical problems. The perception of mechanical purity is partly contrast-driven. As modern vehicles become increasingly digital and automated, older machines feel more authentic by comparison. The simplicity becomes refreshing. There is also psychological nostalgia at play. The 1970s represented a transitional period between pure mechanical engineering and early electronic integration. Vehicles from that era capture a balance. They are advanced enough to be usable, yet simple enough to remain understandable. Driving a 1970s classic requires participation. You warm up the engine patiently. You listen for unusual sounds. You anticipate braking distances. You respect traction limits. This relationship builds attachment. Modern cars often prioritize ease, push-button start, automatic climate control, adaptive cruise. Lane assistance. The driving process becomes smoother and more efficient, but involvement becomes optional rather than essential. The raw feeling of 1970s classics is not superior in objective terms. Modern cars outperform them in acceleration, braking, safety, and efficiency, but performance metrics do not measure emotion. They do not quantify mechanical conversation between driver and machine. What enthusiasts seek is not imperfection itself, but connection. In older cars, systems are visible and understandable. Cause and effect are immediate. Press throttle, engine responds. Turn wheel, chassis reacts. There is minimal interpretation layer between intention and outcome. As automotive technology continues toward electrification and autonomous capability, the contrast will grow even sharper. Electric powertrains deliver silent acceleration and instant torque with minimal vibration. Autonomous features reduce driver input further. In that future landscape, fully mechanical classics may feel even more distinctive. The reason 1970s classic cars feel mechanical is simple: they are mechanical. Their systems rely on physical linkages rather than digital mediation. Their imperfections are not hidden, their feedback is not filtered, and in a world increasingly shaped by software, that physical honesty feels rare.